Okay, so we just finished the mysterious tape lab, and now we're going to start looking into electrostatics and what is going on in that lab, and kind of the beginning of our electricity and magnetism unit in AP Physics 2. Electrostatics, if we just kind of break down that word, we are looking at electricity, or something that deals with electricity, and statics, so non-moving. So we're looking at non-moving electric things, and it's not exactly electricity, but it gets to the idea of it. So these are electrostatics here. Now, just for completeness, I'm going to put out here some things that you might already be aware of through your either prior physics courses or your chemistry things. So if you want to up this video to 1.5 speed to get through a little faster, I don't have a problem with that. You do you, okay? But the first thing we need to talk about is just the idea of a charge, okay? So charge, which we're going to use the variable Q to represent it, because that makes sense. The letter Q doesn't exist in the word charge at all, but that's fine. And a charge is a quantified amount of either an excess or a lack of electrons, okay? And the idea of it being a quantified amount is very important. So it is a quantified amount of excess or a lack of electrons. And I get sick of writing the word electrons 1,000 times, so I'm going to write electrons as E with a negative on top of it as the exponent, okay? So that's an electron right there. Now, it's important that it can be either an excess or a lack of these electrons, because if we have just an electron by itself, that electron has some charge on it. It has a very specific charge that we'll talk about in a later video. But that electron has some charge on it, and it is negative because it's an electron. You probably remember that from chem. If we have an object, though, an object has lots of electrons and it has lots of protons associated with it. They have positive charges. Now, we can't really remove protons from something easily. If you do, you've done one of two things. You split an atom, which goes boom, and we get atom bombs, or you've become an alchemist. And if you know how to do that, we can make a lot of gold and we can make a lot of money and flood the markets. But that's a different issue. So if we are lacking electrons, which we can easily move, well, easily being a relative term, but much more easier than protons. If we can move electrons either on or off of something, we can either say it has an excess amount of electrons or a lack of electrons, and a lack of electrons would cause things to be positively charged. Now, these have to be quantified amounts. We have to count in a specific increment of charge due to something called the elementary charge, which we'll cover in a video, 2 videos from now, okay? But that's the general idea of charge right there. The other topic that, maybe you've looked at this before, maybe you haven't, is an electric field. So the electric field is going to use symbol of a capital E, and it is a vector. So we're going to put a vector arrow over the top of this E here. That represents the electric field. And the electric field is defined as kind of a mathematical way, but it is simply a force per unit charge. And this idea of a unit charge is going to make more sense as we kind of dive deeper into this unit and we start talking about test charges. But mathematically, we can write out an electric field equation. We can say right now that our electric field is simply equal to a force, forces are also vectors, so make sure you put the arrows on them, divided by, so that's per, unit charge. And we know charge is a symbol of Q. And that is an electric field there. Because of this, we know that the electric field must have units of newtons per whatever the charge is. And we use coulombs as our units of charge. So if we're looking at units of charge, we're going to use C, which stands for coulomb. So our electric fields are in newtons per coulombs, okay? And that is a uppercase C there, not to be confused with the tiny c for like degrees Celsius. It's newtons per coulombs, okay? So this is just some intro material that we need to keep in the back of our pocket as we're going through this. We're going to be talking a lot about charges. It's going to be like a fundamental thing in this course for this unit. And electric fields are the first thing that really pop in for us and what we need to start thinking about. In our next video, we're actually going to have a little bit of a flashback to what we did last year regarding gravity, and we're going to look how this electric field force per unit charge is actually very similar to something you've already done last year, okay? But until then, adios, take it easy, best of luck, and see you later.